My name is Ming Dong. I work for Minitab. I've been working with Minitab for 18 years. Yeah, since the office opened in Sydney. So today I'm talking about Minitab, and mainly we talk about applications, Minitab applications in mining and government. So this is the topic we talk about. When we talk about Minitab, we say we've been in business for almost 53 years. Yeah, established in 1972. But we always, as a Minitab, we always follow guidelines. Let's say that is to produce a software, powerful statistical software that everyone can use. Doesn't matter you're a data scientist, you're the statistics or statisticians or quality professionals or people with data. As long as you have data, we try to help you. That's why we have standard statistical tools like ANOVA regression, DOE reliability, but also we have tools like Minitab Assistant, help people to use Minitab, quickly identify the tools and click, everything done. Graph Builder to plot pictures or graphs easily. And also recently, we're adding machine learning algorithm into the application. So also we have a global support system, like to help you solving problems. We have tech support training. We can do online, on-site, and we have consulting, and also we have comprehensive a system of help system called online building help system. When you use the Minitab, there's no coding. All right, this is guaranteed. You just click, you get the answer. Over the years, we have improved, especially in the last 5, 6, 7 years, we're adding many features, including the algorithm, including the algorithm improvement and architecture, and also online, which is a cloud product. We're putting Graph Builder, we're putting all the machine learning algorithm like a TreeNet, random forest, and Mars. So all this has already implemented in Minitab. So now it's a very powerful tool to help you as long as you have data. So first I talk about Graph Builder. We have customers always ask us, oh, you have so many graphs. I don't know which one to use, which one to pick. What about I want to change the view quickly? So I have so many options. Which one should I choose? So many of these questions. So we build this called Graph Builder to help you quickly use generate some pictures first. Then you pick out which one you want. Of course, with data visualization, we can take quick actions, especially for decision makers. If you see a very nice graph, you probably take quick action for business growth, hopefully. And you can also find error easily. If you think about histogram, you may see outliers straight away. And also you can see normality, you can see bimodal data straight away from a graph. And also if you see some correlations, that's very useful for business, right? Identify the business insight. And also you see the time series plot, you can see you can easily capture the trend of business. So you can take action early. So these are the benefit of graphical analysis. Normally it's the first stage when you have data in front of you. So let's use a mining example. For example, I'm talking about the dump truck tire life. So these trucks very huge, and also those tires going to be very expensive. So let's say we have two different type of tires. One is durability, one is more like general. And also we have two different brands, A and B. So over the time, we purchased a mix of durability tires and also general tires and different brand as well, A, B. So I record their lifetime for each one. Suppose this is data. We have many data we didn't put it in a screen. So I want to find out, okay, which one is better, brand A, brand B, or which type of tire should I use, A or B? So this is a question. Can I solve it with Graph Builder? Okay. So when you click on Graph Builder, that's a screen in front of you. And what you need to do is just look at this circle. You just drag those variables. For example, the durability general type of ties and the brand and lifetime. I just drag it, put into the box. So MeetApp Graph Builder can give you all the possible graphs based on those three different variables. You can have histogram, probability plot, heat map, and bar chart. So if you want to try, just click on it, right? So have a look. You are happy or not happy. So which means in our case, I'm going to choose box plot. Then we give you the box plot. It's clearly marked as these are durability ties, and these are general ties. You can see the central tendency for A brand and B brand. If I will say durability ties, A is better than B, right? Central tendency. Variation could be similar. And for general, also, A central tendency is higher than B. It's a median number higher than B, but maybe big variation on A type. So I can have a quick understand of these types. Maybe you probably say, looks like doesn't matter which type, A in general is better than B. And these graphs are interactive, which means you put your mouse over it, it gives you details of the ratings of the chart, give you percentile, median, etc. So this is going to help me understand Thai life just using a picture or graph builder. Then let's try another mineral example, for example. So we collect rocks from different locations, right? So it's a different type of rocks, or we try to do some mineral process. So the data just represent different location from 1 to 11, different location. So the location, then for each location, I examine, right, a rock, for example, components for iron, for copper, zinc, silver, gold, tin, etc. So these are the rating for this location, this kind of rock, and these are the 11 different location. And it's just like a data of 11 location, but the dimension is something like 6 dimension, right? So how to compare, how to draw some pictures. Same thing, we just drag and drop those variables into the box. Then Meta give you all the possible ways. You may plot time series plot, you may have bar chart, you may have like a bubble plot, options as well. So this time I choose what we call parallel coordinate graph. So this graph just like we're based on the ingredient amount, percentage or amount. So we just join each line like this. So each one single color represent the ingredient of one location over 6 dimensions. You can play with this graph, like turn off, turn on, just like to compare. I can find out. So in this case, I look like P10, which is location 10, and location 8, pretty similar. Example, except the iron. So if just, but I have limited knowledge in mining, right? So just if the difference is okay, the very similar, we just say, suppose we just produce silver. So can I use similar process parameters to process these different rocks, right? So could be similar, which means when we process them, could be similar. So we're going to save a lot of things if we're going to do the processing. So these are just graphical analysis to understand different rocks over different components. Let's use a government example, right? So for example, we have big province and many counters over different regions, right? We receive complaints all the time. So definitely management want to reduce the complaint, try to figure out which is a pattern, or I'm looking for some hotspot I try to study the area to reduce the complaints. So data says something like we have recorded time, like April and May from different region, and also even different region, different date, different time. I also identify the age of the people complained. So 0 to 49 and 50 and older. How many complaints? So that could be many, many lines of data over several months. So how can I identify something, pick out something, interesting pattern or hotspot? I want to reduce the complaint. Same thing, I just plug in those variables into the graph, into the box. And also you have function here because you say, are you looking for plot the sum, total complaints, or you are going to plot the average, or you can have standard deviation. So many options here you can choose. So look at the graph. We plot over time, which is a horizontal as a vertical, and also horizontal. I group them into four different region, two different groups. That's 0 to 49 and 50 years older, and then group further by the region: Middle West, Northwest, South, and West. And also you see some colors, which means the color represent the number, total complaints. If it's red, that means high number. And if it's dark blue, which means low number. So I can quickly identify Northeast, 50 years old. This group in April, they complain a lot, which is the highest number. But this number also reduced in May and further reduced in June. Okay, understand. But the other pattern in West, over say young people, 0 to 49, West, their complaints increasing over time, from dark to light dark to white and to red. So it's increasing. So we can see patterns and also we can see some hotspot. Then the manager probably can set up program, how to deal with these regions, how to set up quality improvement program. So this is the first step we call data analysis using Graph Builder. Okay, let's talk about some case studies. So this is an Australian mining company. They have 4,500 employees and some contractors. They have a large haul of trucks descends a narrow ramp down to the bottom of an open pit, right? Open pit, the mining site. So they can, over there, the truck's gonna pick up and average about 250 tons of ore to carry back for crushing. But the problem is they experience slow trucks. Those trucks very slow. But the problem is a slow truck gonna also delay the old trucks behind it, which means not efficient for those trucks. Those trucks are very expensive, of course, going to be utilized. So they identify some factors, try to improve the truck speed. So what they do, they change the ramp grade, change the grade. So hopefully they try to say, I want to improve the truck speed. But is this a valid study? Is this a correct way to analyze? So they use statistics to analyze, use hypothesis testing. So what they do, they record the truck speed before they change the ramp grade, and also after they change the ramp grade. So they want to see the difference. And the engineer is not a statistician, so he doesn't know how to do, how to run the analysis. So they go to Minitab, they use this button called Assistant. So in the Assistant, when we choose hypothesis testing, we give you such a page like ask you to choose. For example, you're comparing one sample with target, or you're comparing two samples with each other, or compare more samples. And the guy, not very sure, he click on help me choose. Then we have pop-up page, okay, tell you, do you have continuous data? You can have attribute data. The guy still don't know, so click on data type. Then we'll give you explanation. What is continuous data? What's attribute data? So further You just click here, and also they come to the right page, right? It could be two sample T when we come to the, so we have some two sample T. So that's the result. So we also give you a report in the assistant manual. We write a report for you. It says the mean of after is significantly greater than the mean of the before, which means speed getting better, higher. And you can be 95% confident that the true difference is greater than 1.74. It is like speed increased at least on average 1.74 kilometers per hour. So they're happy with the result, and they predict actually the project saves them almost like 35,000 just for the first year. Okay, next we talk about silver recovery. All right, for silver mining side, this is one of the largest primary silver producer. They holds lots of very large mining site with precious metals. The problem is they try to maximize the silver recovery rate without diminishing the grade of finished silver concentrate. So we should control the concentrate, but maximize the recovery rate. When we do have mineral process, the ore is ground and the raw material is a process to extract lead, zinc, some certain like materials in components than before you get a silver. So there are some parameter when you process talk about silver process parameter. We talk about promoter, we talk about reagent, we talk about process. Yeah, process. So these are the parameters we need to consider. Then how to set up these parameters to maximize the silver recovery rate. They choose DOE as the tool to analyze. So they're going to design, first they have designed the study, which means looking for all the combinations of promoter, reagent, and force air. So all combinations. We have A, B, 30, 10, 6, 10. So you can run multiple times, or we say replicates, many replicates. Then you get the data in random order, right? Also run this in random order. Then use this to analyze. DOE is a controlled study, of course, everyone understand. So it must be done properly. So the results, they analyze promoter and reagent. These are the key drivers. The other is not. And they have the equation. Of course, equation, you can use equation to predict. We have also draw some pictures. Can tell you the interaction between reagent and the promoter. How this can affect the silver recovery rate. So that's a relationship. It's like a twisted plane, a little bit twisted because of the interaction. And also we give you the contour plot because based on the model, we say the contour area means within certain area, for example, I'm talking about this line. This line is between the recovery rate between 55 to 57.5. So this is a region. So if you are looking for maximize, I probably go for this small region, which is over 65% recovery rate, which is reagent 10 and promoter 2. That's this small corner. But however, people always think about the best option is, of course, some limitations, which means it could be not practical. So this graph, we can use many tabs, you can figure out, go to each the dots. It tells you what's the promoter, what is the reagent, what is the recovery rate. So you can go to any single dot. So you use this option, you can identify the practical settings, not always optimal, right? Optimal is not always practical, but the only thing you can do is a practical and also best option you can. So use this graph can identify where I can set up the promoter and reagent. The optimal point normally is not practical. All right. Next, talk about government agencies, talk about city transportation department. So if you are trying to optimize traffic flow, right? For example, in a certain intersection. So we can set up many options. For example, signal for timing, the traffic light signal timing, and the speed limit. So you set up different speed limit and different track signal timing. So which combination gonna maximize vehicle flow? So this is a question. Again, people always think about DOE is in manufacturing, always in manufacturing, but we can also apply DOE in government and the services. So what we can do is set up different speed and different signal timing. So a combination again, and the replicate design multiple times. So it depends on your budget, depends on your power you're gonna achieve. So we can maybe go to one location, right? Suppose we think about one intersection. So we go there and figure out a certain time, and we go there multiple times, many ways. That's run your experiment. We record the traffic flow, vehicle flow, right? How many cars passing by in a certain time. Then the diagram or the first when you run the analysis, put in Minitab, we see the term A, B, and AB, which means speed and the signal timing and interaction, both or all of them are significant. So if all of them are going to be significant, I'm really going to interested in interaction. I can't just look at it, A, B, and just forget about. So which means think about A, you have to consider B. That's what interaction is significant. So we have the graph we call the interaction plot. So very straightforward. If you want to maximize the traffic flow, the speed should be 50 and your timing should set to 70. So this dot can give us the maximum traffic flow. And the minimum going to be somewhere here. Which we don't want to run this at this location, at this setting. All right, so single DOE study also can help in mining and also in government, no problem. So with a DOE or scientific study, we can identify best traffic flow. We can have a best configuration and also improve intersections throughout to reduce the vehicle wait time. Of course, safety also a big issue, and also you can justify your spending because the taxpayers' money. We can just the infrastructure investment, of course. Next topic, we talk about asset management maintenance. Assets is big issue, a big problem, definitely big cost for mining industry. So suppose we have this expensive engine, very expensive. So which means if there's a problem with this engine, I have to fix it instead of replace it. Replace it can cost very even huge, right? So I have to replace it. So I have to fix it. So then for this typical engine, the engineer record the unscheduled maintenance action, which means the machine run suddenly failed. I have to identify and fix it. Then maybe after some hours, then failed again, and I record it and I have to fix it. So the data just represent the accumulated time for the operating. So like first 860 hours cost me 58K to fix the problem. Then accumulated hour at 1,258 occurred again, another failure cost me 153,000. So that's, you see the number goes up, right? So because the engine gonna keep on running, cumulative hour goes up, and we have some cost to fix the problem. The question is I have many this type of engine. I try to study the lifetime of one. Hopefully, I can apply to others. So this unscheduled maintenance, should I repair it? Should I retire it? What about the cost? So this is a question. Can I afford to keep it? Okay, so first, let's plot engine failure versus time. So here, this graph, just like this is running hours, right, over time, about 4,000, 4,800, and also the failure time, where it's failed. If you look at this graph, you probably say, if some dots are very accumulated in certain area, that could be something we could be concerned about. And what about is it spread out, or is increasing the density or decreasing density? So these are the patterns we're looking for. We also can plot like this, we call mean cumulative function for engine hour, which means every time there's a failure, a plot go up by 1. Then also at different time. So the graph can be something like this. This actually same graph, just in different way. So if I look at this graph, if it's kind of straightforward, which means failure rate could be constant. But if the curve gonna be like this, which is going up then getting flat, we call concave curve. This means the engine is getting better. When you run around, it's getting better. If that's like a curve like this kind of style, we call convex curve. Then the engine could be getting worse, which means over time, the failure rate increasing over time. So this is something we need to look at it. Then in Minitab, we can run test, we call trend test, right? Whether the failure rate increasing or decreasing or constant. We have the p-value, give us the value 0.597, which means it's greater than 0.05. We say the failure rate is constant. If we have this failure rate is constant, we can calculate the mean time between failure, which means engine gonna fail unscheduled failure on average 857 hours. Then that could be expecting a failure. So that's something very useful for maintenance team, how to schedule the maintenance. And also talk about cost, right? Because we have the cost graph, cost recorded as well. Again, the same thing at different engine time, we just put in the cost for each failure. Look at the curve, something like this. You probably identify from 0 hour to 40,000 hour, it's like follow slope, a steady slope. But over 40,000 hours, it follows different slope, which is slope getting bigger or getting deeper. So we can identify as well, say over 0 to 40,000 hours, the total cost is about 7.2 million. But for the last 40,000 to 48,000 hours, the cost is about 3.2 millions because it's getting increasing. That's cool. The cost getting higher, okay, higher. So now if you have those figures in mind and you have many different machines like this, you can think about, should I keep it or should I retire this machine? So that's your call. But the data definitely help you to make a decision. Okay. Now we talk about machine learning. When we bring this topic, it's just like before, maybe 20, 30 years ago, I was doing regression analysis and ANOVA analysis, which is we have the number of data is not that huge. But now with advanced computing technology, we have large data sets. Large data means many variables and over many rows of data, which you talk about variables and also number of rows data. So then if this is the case, we say p-value is going to be meaningless if you have large volume of data, and the variable going to be very complicated, the relation going to be more complicated. So we're going to use machine learning. So machine learning is a kind of a combination of modern stats and computer science. It's combined together. And because the advantage is it can deal with lots of variables. So it consider all the variables together. And also relationship could be nonlinear, could be local relationship, could be very complex relationship between variables. Also can handle missing value. Missing value means it can find a sort of variable correlated very close to that variable and replace the value with it. So we don't have to get rid of the data, because if you regression, if one observation is missing, that line's gone. We're not going to use that. But in machine learning, we can utilize the missing value using different techniques. So that's a trend. So Minitab, we have to implement this in Minitab. Yes, we have it. When we do the survey, not this one, the survey by survey, this company did a survey on this website. So talking about what about the obstacles, right? People talking about predictive analytics, data, big data. What is the biggest obstacles? So first is not enough analytic skills. Then the third is inadequate technical skills. So Minitab tried to solve this problem because these are the two things that block people using data, especially big data. So we provide a suite of cutting-edge algorithms. So Minitab, we're bringing linear regression, logistic regression, CART classification, and random forest, and the TreeNet, and the Mars. These are all the award-winning algorithms, right, developed by professors in Stanford and other universities. So Minitab purchases this company and put in all the algorithm in Minitab now. We call this predict analytic module. So we can have a separate module, which is a picture showing here. And furthermore, we also have this called automated machine learning, which means we're gonna run all possible algorithms and we find the best one for you. We identify that. Also, you have options to choose the second best, the third best, or fourth best. You can choose which one to use. So when you run automated machine learning, we run all the algorithms, some algorithm, we give you multiple options. So totally about 11 models we can build, and you just choose which one you're going to use. Okay, let's say tax authority. How to identify fraudulent tax returns, right? Always people going to try to hide it. Focus most on underreported income, right? People hide income. So they can, through analyze the demographic information, such as incomes and filing patterns, their income and their gender, whatever. So let's see this example. So this data set just based on history data set, right? So we have people, they don't have fraudulent, or yes, they do have fraudulent income. So this is yes, no, just like my answer. So in the data set, we can have individual say this person's age, is credit limit, education level, gender, and home size, income, marriage status, offshore transactions, number of credit card, whether you put an occupation, you put it blank, or you fill out something. So someone try to hide their occupation. So don't fill, or something they fill. Yes or no. They rent a house, how about rent? The parents or the missing. So we can have missing values. Employee, number of years employee, and where you live. 1, 2, 3, 4, 5 means 1 could be in the city center, 5 could be in the outside suburb. So these are just basic information, but we know the result. They are tax fraudulent or no tax fraud. So how to use the data? Putting Minitab, run analysis, okay. Then you will have a decision tree structure. This is a basic, we call CART tree. This is a basic or foundation for all the algorithm in Minitab almost. So what does it mean? So we start from the beginning. So I enlarge this node, we call root node. So totally 30%, yes, which means tax fraud, 30%, no, 69%. All right, this is a root node. We try to split, binary split. How to split? It means we try to maximally separate fraud and no fraud. all right? Just a basic. That's how you build up this tree is maximum separate float, no fault. By going through all the variables and all the possible ways to split data into two. So you can think about how many variables, how many ways to split the data, go through all the values within the variable. So the calculation is very intensive. Then we build up this tree. Then we have intermediate node. We also have terminal node, which means end of the tree, right? Which is nothing under that. So let's look at the story. What does it mean? Just go by this track, for example. So this, we starting with 30% failure, which is 30%, these are the fraud, tax fraud, right? And then go down to offshore greater than 1.5, number of offshore transaction, and post being greater than 1.5, and the offshore transaction greater than 4.5. Then you come to another, we call the terminal node. If you look at terminal node, now in this group, we have the chance for yes, which is tax fraud, jump to 72%. Starting from 30%, jump to 72%, almost 2 point something percent higher. So if this group, the chance I can capture the yes is much, much higher. It's also giving me a certain rule, right? This group, I have to pay attention. So these are the, if you look at this row as well, it's another track with very high, which is blue color, which means yes, chance of yes is also very high. So the first rule is if the offshore transaction greater than 4.5 times, posting greater than 1.5, the chance of tax fraud is 72%. The next track, I analyze this track, is credit limit less than 55446, offshore transaction less than 1.5, post being greater than 3.5, and they are married as well. Their post, the chance of tax fraud jump to 80.2%. So if I'm a tax agent, I'm going to focus on this group and capture this group first. If it follows patterns, then keep further study, make sure. So this algorithm can help you find the high risk group, right? So this is called high risk group, and easily. So looking at further, what are the most important variables? We say relative important variable. First is post bin. Where do you live? If it's within or outside skirt, outside the city center. Number of transactions is another key factor, and also gender as well. So these are the first top three drivers, right? Or associated variables associated with chance of tax fraud. How accurate? If I use this model, the tree actually is a model. So if I use a model to apply to further or apply to my population, if the tax fraud events, which is an event, you can capture it 81% of the time. If no, 75. So starting using the model, I can capture tax fraud 81% of the time if there are. But initial, if just based on average, it's only 30%. So tax fraud pattern, we can identify these patterns faster and more accurately. So you can running the algorithm just like 0.2 seconds, you get an answer straight away. Of course, reduce manual work. Lots of animation costs can be reduced and improve tax compliance and revenue collection. This is how you're going to apply in tax agent, apply Minitab machine learning. And then let's look at another mining example. We talk about predicting engine failure. You know, if your engine gonna fail, definitely gonna is a big issue, right? It costs me more, lots of, I really want to identify and further, which means I want to reduce the chance. Also, if you're gonna close to fail, I try to identify, probably I want to stop the machine instead of let the machine fail. So we try to predict engine failure. Let's say So we collect data. It could be historical real-time sensor data over many, many years. So for example, so we have this engine. We collect about 10,000 historical sensor data. This engine status data, talking about different engine, what is the air temperature, what is the process temperature, what's the rotation speed, what about torque, what about tool wear, what about the status, machine is a failure or non-failure, 0 or 1. So you see not many chance that engine gonna fail, not fail every day, right? So the average failure rate is only 3.3. So over 10,000 historical sensor data. The failure average is only 3.3%. Then we apply Minitab P predict analytic module. So we can identify what are the key drivers. Torque is the most important, and then rotation speed, followed by tool wear. How accurate the model is, if there's a chance of failure, we can capture it correctly, identify correctly 75% of the time. If 0, which is no failure, 98% of the time. The 75 is the most important I'm going to read because I'm interested in failure. So starting from beginning with, if you don't apply any model to identify certain conditions, for example, the chance is only 3%. But if you apply the model with price algorithm, you can apply correctly, identify the failure correctly, 75%. That's a big improvement. So, and also we can plot this graph called the partial dependency plot, which means to tell you how the torque gonna correlate it, what's gonna different torque gonna associate with a chance of failure, which is a log odds for machine failure, which is chance of failure. So we can see clearly if the torque is somewhere between 20 to 40, maybe 45, the chance of failure, machine failure, gonna be low, right? And also we see the variable rotation speed also important. Okay, what about the combination of torque and rotation speed? So this is a 3D graph. Minitab generates 3D graph. You can play with it and spin along the X, Y, Z. You can see the graph. You can see how the combination or interaction between torque and the rotation speed, how this going to affect your chance of failure. We can see somewhere in the middle, right? Or could be, you can see it's like rotation speed around 2000 and torque could be around 40 or 35. That's area you have low risk of failure. So Minitab can use this model to predict failure because if you have a certain condition, quickly you will apply the model. It tells you chance of failure or we high chance of failure or low chance of failure. And further, you can use DOE study, right? Talking about torque and rotation speed, maybe tool wear, how to control these 3 variables because these are most important, maybe followed by air temperature you try to control. So we try to find optimal condition, minimize the chance of failure. So that's the next step. You can do DOE study. Yeah, it could be a very good DOE study to start with. Or maybe other process improvement project. Okay, then you talk about real-time SPC. Real-time SPC is very popular tool. Even in Minitab, SPC is first popular tool in Minitab. Everyone understands real-time SPC, process control. We plot data, we can identify the special cause variation, of course, or assignable causes, right? We plot, also we check random fluctuation and identify which is possible assignable causes, which is due to some noise. That's what I try to differentiate whether signal or whether it's a process noise. We use Nelson rules. And the most important, we try to shift from reactive to proactive by applying real time. So if you don't have real time, you could be get the data maybe one day later you can look at a graph or something wrong, you identify. It's called reactive. But if you can get the signal, some possible assignable courses in real time, you can take proactive decision because you don't want to generate some failures where the dot's going to be outside spec or outside auto control. So this is something why we need to use real-time SPC. Real-time SPC can detect some assignable courses like some patterns. These are the rules. Nice rule. We'll talk about different patterns. Just quickly go through a few of them. For example, one dot outside 3 standard deviation. By chance, it's only 3 out of 1,000. Very low chance. We probably say unlikely it's due to some random stuff. It could be due to some assignable courses. Also, 6 dots in a row going up or going down. Looks like a trend. We say identify there's a possible trend in your production line. You try to control, otherwise it goes very quickly. So we can send you a signal. And the 9 dots is under or below or under the average or above average. It indicates some shift, a production shift. And also some 14 points in a row, up and down, right? Up, down, 14 in a row. If you ask people on the street, they will say, is it normal? They probably say normal. If this is normal, I would say I'm not going to work as a statistician. I'll probably go to casino, go for black, white, I win millions. So that's why this is very, very low chance. You can up, down, follow this pattern. And others also detecting low probability, right? So all the purposes detecting low probability that could be due to some assignable causes. We send you an alert. So real-time meantime, we have this new product which is called real-time SPC. It's a cloud-based product. We control and monitor real-time, right? We send the data into cloud and send message to you, so you can use the iPad or in front of a computer. You can see the production line in real time. It integrated into the data collection, and integration also going to be implemented. We send a message, which could be alert message, for example, text message or email to send you alert in a short time. And also you have capability plot, shows you how capable your process is. And the data you can even further send to Minitab to do root cause analysis, right? So this is a new product we developed in recent years called real-time SPC. So some mining applications, for example, talk about all grade monitoring, right? So real-time sensor to track variations in the ore grade over time. If the gold, for example, gold concentration over certain threshold, then the signal, the SPC chart can send the signal, maybe cause some reactions like triggering the blasting, crushing, blending, some adjustment. So these are very typical to monitor all grade monitoring. And equipment vibration, yeah, this is a big issue for especially in big expensive engines. So if the vibration levels exceed a certain control limit, we have to do something. Either the maintenance team can do something or stop the machine, right? Don't experience some failures. pH levels, especially mineral process, is going to be controlled. If over a certain level, we have to do something. And the air quality is a big concern for mining. So if the dust exceeds certain level, the sensor can capture the numbers, right? And send to real-time SPC and trigger some adjustment, for example, ventilation system or some other things. So these are the popular applications in mining using real-time SPC. Okay, so today we talk about real-time SPC and we talk about Minitab, lots of applications. Minitab have other products. These are the product suite. So we have Connect, which is the data wrangling, collecting data, or especially you have multiple data, we can collect over them and run something. gave you a summary report dashboard. And we have Meta Model Ops, which is a deployment, talk about model deployment. Workspace and Engage, these are for project management. Education Hub for self-learning and improvement, so you can learn stats, learn Meta in one online platform. And this is the end of my talk, and appreciate your time, everyone. And if you have any questions, I'm ready. Hopefully I can answer your questions. Yeah. Hello?
Yes, thank you. Thank you, Ming. So are there any questions from the room?
Oh, hello, yeah, so,
Can I just ask the question or should I put it in the chat?
Either way, you can put in the chat either way.
Thank you very much for the interesting discussion. You see, a lot of people nowadays are arguing that Minitab cannot handle enough number of data, or is not very useful for a large data set. So in the latest version, do we have a limitation on the number of data that we can use in Minitab?
Okay, this is a very good question. I tell you the truth, in terms of data handling, our capability is much bigger now. In one single worksheet, you can have 4,000 columns, 4,000 columns, and 10 million rows. But the combination of number of cells is 100 million.
Okay.
So I won't say it's big because some application definitely can handle larger, but it's for a certain purpose. The Minitab is not for transactional business kind of data handling, but it's for quality project or big data analysis. So this is good enough normally. So total number of cells, 100 million. That's the capacity for one worksheet.
Thank you very much.
Thank you.
yeah, Alex, thank you. Thanks for the talk. Showing the age, but I remember upstairs at the laboratory at UWA in the late 90s, we used Minitab, and as did the engineering students here. And since then, used lots of different software. Haven't used Minitab since, but is it particularly used by engineering firms, or I mean, it seems like some fields have their preferred software, right? Their SAS or
Yeah, your sound very
science or business, finance, whatever. So where's Minitab predominantly used these days?
Is this a question? I can't hear you properly. Maybe some bit weird. Minitab, we have originally, so we're talking to color quality people. Now we extend our capability. So which means as long as you have data, definitely we can help you in some way, but definitely not everything, but definitely going to help you in some way, because look at the easy to use. That's how we help people with different background to use the Minitab, not just limit to quality people. Yeah.
Yeah, you have some really good engineering type applications. So I was wondering if that was the main area that you focused on.
Yeah, engineering is our big user group, definitely.
Thank you.
Any other questions from the room? No, I don't think we have any more questions. If not, let's thank Ming once more, and we'll draw our event to a close.